Hello, Algebra 1. These are your notes, your flipped classroom lesson on how to graph a quadratic, and this is your introduction to graphing quadratics. So you're going to go ahead and do these examples and copy them on a sheet of paper and turn them in tomorrow for credit for tonight's homework assignment. So let's take some quick vocabulary for quadratics, quadratic graphing. So for vocabulary, I want to remind you what a quadratic function is. In class, you heard me call these quadratic equations. And in standard form, it's known as y equals ax squared plus bx plus c. Now you'll notice in class we were saying ax squared plus bx plus c equals 0, and the reason we were having it equal 0 is because we were trying to find the solutions for x. We'll get more to that here later on in these notes. So we know where the a's are, we know where b is, we know where c is, and we're comfortable with that because we've practiced with the quadratic formula. Alright, another vocabulary word that you need to know is the word parabola. I'm going to write that right here. Parabola is a U-shaped graph. So at the beginning of the year we were doing linears and they were straight lines. Quadratics are all going to be U-shaped, also known as happy faces. Well, along with every happy face we also have sad faces. So we have the phrase opens up and we have the phrase opens down. For opens up, it is a U. For opens down, it is a frown. Okay. Other vocabulary words I have for you are vertex. Vertex is the highest or the lowest point on your parabola. And the axis of symmetry is another important phrase. The axis of symmetry is a vertical line that's going straight up and down, and it's imaginary, and it passes through the vertex that's the highest or the lowest point, vertex, and divides the parabola in two. And it's into two equal pieces. What's on the left side will equal what's on the right side. In a nutshell, those are all the vocabulary terms you need in order to graph a parabola. We're going to go into the parts of a parabola, so go and pause if you need a copy of that vocab down. Otherwise, we'll proceed with the notes. So let's describe the graph of a parabola. Let me draw an example parabola for you. So just like we did with our linear equations, you have an xy axis. X is horizontal, y is vertical. And let's just say I have a graph with a point here point here and there. Then the next point goes up to here and here. You're going to connect those dots. If I can just get this right with the stylus, it's a little funny. There we go. And you see something that looks like this. A couple of important points to notice here is that this point is your vertex. That's the lowest point on this parabola. If I were to take a horizontal line, like this one, let's see if I can grab this horizontal line. Oops. Now it won't let me grab that line. What I was going to try to do is move that line upward. Imagine that line moving upward towards the parabola. The first part that it would touch of that parabola is that lowest point, and that's called the vertex. Alright. Also, it's important to note that there are some whole numbers here that help guide us. Like here's a whole number point and another whole number point. That's 0.1, 1. On this one, this is 0.2, 4. Over on the other side, we have -1, 1, and we have -2, 4. Another important piece here to recognize on this graph is your axis of symmetry. The imaginary line that goes straight up and down vertically goes through the vertex. Imagine as if that were a mirror. What's on the left will equal what's on the right. They should look pretty identical. This happens to be the graph of y equals x squared. Notice there's no b term and there's no c term involved, and this graph does open upward. So there's an example. This is example 1 of the vertex, the line of symmetry, and how this graph opens upward. Alright, let's talk about example number 2. So if you need to continue copying that down, go ahead and copy. Otherwise, I'm going to open up a clean sheet. This next part here. Now let's do an example where you are actually trying to graph a problem instead of just recognizing what the vertex and the line of symmetry is. So we have x squared minus 2x minus 3 as our example. Looking at this quadratic function, we know that a is equal to 1, b is equal to -2, and c is equal to -3. Just like our quadratic formula, we know it's in standard form. We know what a, b, and c are. The first step you need to do in order to graph it is you need to be able to find the x value of the vertex. Now what I mean by find the x value of the vertex is, going back to this example, we said this vertex right here is 0, 0. That's the vertex, and the x value is the first part of that vertex. We need to find the x and take that and plug it back into the equation to find out what the y value is. And there's a formula to find the x value of the vertex. That formula is the opposite of b over 2a. That might look familiar to you, and the reason it might look familiar is because of this: the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I had you guys memorize that for the last benchmark. This piece is just the opposite of b over 2a, just that. That tells us what the x value is of our vertex. Using that information, we plug in our b and we plug in our a into our equation. So a is going to be on the bottom. Let me reset this so it's purple. And then b is going to be on the top. So b here is -2. A is 1, and it's the opposite of all of that. Well, it's the opposite of -2. That gives me a +2. 2 times 1 is 2. So I get a 1. Now remember, this is the x value of your vertex. That's 1. This is how we're going to find the y value. So to find the y value, you'll need to make a table of values. So you've got your x, you got your y. Okay? And what I typically do is I have my students start off with my vertex. So x is 1. So you're going to take that 1 and you're going to plug it back into the original equation to find out what the y value is. Okay? So when I do that, it looks like this. 1 squared minus 2 times 1 minus 3. Well, that's 1 minus 2 minus 3. That's -1 minus 3. Because 1 minus 2 is -1. And then that gives us -4. So the y value when x is 1, y is -4. The next thing you need to do is you need to come up with a few more values. And what I typically have my students do is I have them pick values of x to the right and to the left of x. So if I have my vertex, we now figured it's at 1, -4. Then 1 point to the right of 1 is the point 2. 1 point to the left is 0. 2 points to the right of 1 is 3. And 2 points to the right is -1. So I have a chart that looks like that. And what you ultimately need to do is take each of these values and you're going to plug them in. Now I'm going to take 2 and plug it into that original equation. Oops. So let's see what that looks like. 2 squared minus 2 times, 2 minus 3. Well, that's 4 minus 4 minus 3. I can tell you right now, when I simplify that, 4 minus 4 is 0, minus 3 is -3. We then repeat the process for 0. I'm erasing my work because I don't have enough space here. 0 squared minus 2 times 0 minus 3. Well, that's 0 minus 0 minus 3. So that should give me 3. -3. I'm going to go ahead and go in again and this time put in a 3, so 3 squared minus 2 times 3 minus 3. Well, that's 9 minus 6 minus 3. 9 minus 6 is 3, 3 minus 3 is 0. Alright, and now I'm going to do the same thing with my -1. -1 squared minus 2 times -1 minus 3. Well, that's 1 plus 2. That's 3. 3 minus 3 is 0. So now we've got a bunch of points. Just like that first method I talked about when we started to graph a linear equation. I said you can graph these by plugging in x's and y's. There we go, that's better. I'm going to go ahead and plot if I could just get this straight. It's supposed to be a sharp point stylus. That looks like that's about as close as I'm going to be able to get it. Alright, so let's go ahead and plot these points out. I have an x of 1 and then down 4. 1, 2, 3, 4. I know that this is my vertex. I have a 2 and a negative 3. That's another point. I have a 0 and a negative 3. There's another point. I have a 3 and a 0. Be right over here. And then a negative 1 and a 0. There's a point right here. So you can kind of see your U shape already based off of these points that we've found. All you need to do next is to connect those dots. Just get that to undo. There we go. Not quite as arced. It's going to be very sharp, very steep. Most parabolas are. And the graph of this function looks like this. Your vertex is down here at 1, negative 4. This particular parabola opens upward, and your line of symmetry, straight vertical line that goes straight up and down, that goes through your vertex, looks like this. Alright guys, it looks like this video is about 16.5 minutes long. I'm not going to do another example because this has taken quite some time. We'll practice this skill and I'll answer some questions for you tomorrow. If you need to, pause the video, finish copying that down, otherwise it's going to shut down.